Let's take a look at two more examples. And you'll notice as we go through these, the steps that we're going to go through are exactly the same steps that we went through on the two previous problems. It's just different numbers. So here we have the function negative x squared minus 2x plus 8. To find the vertex, we use our opposite of b over 2a formula to get the x value. Here, b is a minus 2. A, negative x squared, is the same thing as negative 1x squared, so a is negative 1. The negative of negative 2 is 2. 2 times negative 1 is negative 2, so we get negative 1 for the x part of the vertex. To find the y part of the vertex, we go back to the original function and put a negative 1 in place of x. So instead of negative x squared, we have the negative of negative 1 squared. Instead of negative 2 times x, we have negative 2 times negative 1. And then we have plus 8. Now here's a spot where a lot of people make a mistake. You don't start by doing negative of negative 1. Before you multiply, you square. You do exponents before multiplying in the order of operations. So the first step is doing negative 1 squared, which gives us a positive 1. Then we do the multiplying. The negative of 1 is negative 1. Negative 2 times negative 1 is positive 2. And we still have a plus 8. All that works out to a positive 9. So our vertex is negative 1, 9. Next, to find the x intercepts, we set the whole function equal to 0. Negative x squared minus 2x plus 8 equals 0. Now factoring when you have a negative in front of the x squared is kind of a mess. So what I would do first with this, just to make the factoring easier, so I don't make mistakes with the negative signs, I would divide all the terms on both sides by negative 1. Factoring is going to be much easier when you have a positive x squared. So doing that, we end up with x squared plus 2x minus 8 equals 0. And now when we factor that, it starts with x squared, so we put an x at the beginning of each one. To multiply to be a minus 8, but add up to a plus 2, we need a plus 4 and a minus 2. And now to finish the problem, we set both of those equal to 0. And we end up getting x intercepts of negative 4 and positive 2, like that. And then last, for our y-intercept is just our constant term, which is a positive 8. So let's put these on our graph. We have our vertex at negative 1, 9. So 1 to the left and up 9. We have our x-intercepts, which are points on the x-axis, at negative 4 and positive 2. We have a y-intercept of positive 8, which is right here. And if you want to, you can go ahead and add one more point to the graph. Because of symmetry, remember, on the left and right sides of the vertex, since we have our y-intercept there at 8, we can see there's going to be another point at 8 right there on the other side. So we've got plenty of points now to graph our parabola. Well, this time we have a parabola opening downward. We'll start at that point, go through that point up there, and then you do stick arrows on the ends to indicate that the graph keeps going. If we wanted more points, we could always plug in -3, 3, 4, 5, 6, or -5, -6, -7. You could always get more points if you wanted to, but as long as you have the vertex and two other points, that's generally enough to get the good graph of the parabola. Let's try one more example for this section. Here we have 3x squared plus 3x. All right, so finding our vertex, we start with that same x equals minus b over 2a formula. So here we have negative 2 times a number. For this problem, b is 3. A is also 3. So we get negative 3 over 6. Negative 3/6 is the same thing as negative 1/2. And since I find decimals easier to work with, I'll just write it as negative 0.5. To get the y value of the vertex, I'm going to plug that back into the original function. So instead of 3 times x squared, I have 3 times negative 0.5 squared. Instead of 3 times x, I have 3 times negative 0.5. Remember, you square before multiplying. So negative 0.5 squared, that's the first thing we do here. It'd be positive 0.25. Next, we do the multiplying. 3 times 0.25 is 0.75. 3 times negative 0.5 is minus 1.5. So here we end up with negative 0.75. So in terms of our vertex, we have negative 0.5 for x, negative 0.75 for y. Next, let's look for the x intercepts. To find the x intercepts, remember we take that whole original function and set it equal to 0. 3x squared plus 3x equals 0. Now we can solve this by factoring. Remember, the first thing you should always try to do when factoring is see if there's a greatest common factor. And here we could factor out a 3x from both terms. When we factor out 3x from the first one, 3x squared divided by 3x is just x. From the next one, 3x divided by 3x is 1. And now we're done factoring. So we take each of these factors and we have 3x equals 0, x plus 1 equals 0. The first one you divide by 3 and you get x equals 0, so that's our first x-intercept. The next one you subtract 1 from both sides and we get that our other x-intercept is x equals negative 1. Now let's talk about the y-intercept for this one. The y-intercept is the constant term. This function doesn't have a constant term. That doesn't mean, though, that there's no y-intercept. Notice this is the same as if you had put a plus 0 there. So when you don't have a constant term, it's the same thing as plus 0. That means that your y-intercept is 0. It's going to cross the y-axis at 0. So let's put these things on our graph. So first, the vertex. This is going to be half a spot to the left and then 3/4 of a spot down. So looking at that on our graph, half a spot to the left, and then it's more than halfway down. It would be 3/4 of the way down. So somewhere around right there, a little closer to negative 1 than to 0. Then our x-intercepts for this one were at 0 and negative 1. So we put points on the x-axis at 0 and negative 1. Our y-intercept was 0, and we've already got a point at 0 on the y-axis right there. So then to finish it, we've got enough points. We've got 3 points. We've got the vertex and 2 other points. We can just draw a curve that goes through those points and stick arrows on the ends.